All right, we're going to pick up where we left off. We were in the middle of explaining this one. We were talking about there are 12 floats in the parade. Their order is chosen at random. Find the probability, that was the key word, that your float is first and the school chorus is second. So probability is the part that we want out of the total. So if we think about it, the part we want is we have 12 options and we only really care, oops, there's supposed to be a P. We only want 2 of them that we really care about. 12 options, but we care about 2 of the order. Okay? The total number of options would be if we have 12 options, how many ways can we arrange all of them? So we're going to actually solve both of these and then write it in the form of a probability, the part we want that we're looking for out of the total. So first, on the top of our fraction, permutations here, we have 12 choices. We're looking at 2 of them. Going back to our formula right here, permutations, remember, n factorial over n minus r factorial. So on the top here we have n factorial over, oops, I'm just going to write n. What is n? So we have 12 factorial over 10, or 12 minus 2, which is 10 factorial. That's on the top. On the bottom, 12 combinations of 12, that's just 12 factorial. So we need to solve this part and solve this part, and that's going to give us our probability. So 12 factorial is really 12 times 11 times 10 factorial. I'm going to stop there because 10 factorial over 10 factorial cancels out. So we have 12 times 11, which is 132, is our answer for the top of our fraction. So far, we have 132 over 12 factorial. So this tells us so far there are 132 different ways to arrange the floats in the parade where you're first and the school chorus or the choir is second. Because you're first, they're second, and then the rest of the people in the parade you don't really care about, but there's 132 ways that we can arrange the rest of them so that you're first and the float with the choir is second. Out of how many total? So we need to figure out what is 12 factorial. What is the total number of ways that we can arrange everybody? So we have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we get an answer of, just for the bottom part here, 479,001,600. This is the probability that you're first and they're second. The part that we could be first out of the total. That is ridiculous. I'm not sure if you have any like this on your homework, but it would help to set it up like this first. The part we want out of the total. Last 3, you do have some like this on your homework. We're just comparing which is greater using our symbols greater than and less than. So here, 12 objects that we're going to arrange 12 different ways. That's just 12 factorial. This is 12 objects we're arranging in 10 different ways. Okay? So this is 12 factorial. I'm just following our formula for permutations, which is n factorial over n minus r factorial. And n minus r is 2, so 2 factorial. So if we cancel these out, this is really, on this side, 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. The 2's would cancel out. If we had 2 factorial here and 2 factorial on the bottom, those would cancel out. So which is greater, this times this or 12 factorial? Well, 12 factorial would include multiplying by 2 and 1. So this is going to give us a greater number. 12 combinations of 12 is going to be more choices than 12 combinations of 10 objects. Or, I'm sorry, 10 objects, 12 ways, 12 choices. Let's look at the next one. A little bit smaller numbers here. We have 6 objects total. We want to look at only 2 of them. So we only care about 2 spots. We have 6 choices for the first one and 5 choices for the second one. Or we could write it out in terms of our factorials. We have 6 factorial over 6 minus 2 factorial is 4. They'd cancel out and leave us with just 6 times 5, which is 30. On the other side, we have 7 factorial over 7 minus 5 is 2 factorial. And that would leave us with 7 times 6 times 5 times 4 times 3, because the 2 factorials would cancel out. So this number, when we multiply it, is going to be way bigger than 30. Here we're only looking at 2 objects, here we're looking at 5. Alright, this next one, just think about each section before we even start solving them. Here we have 6 objects and we're looking at 2 of them. Here we have 8 objects and we're looking at 2 of them. So we know that there's way more objects here, so that's probably going to be more choices because we have more objects to choose from. If you think about having 2 spaces, we're only looking at 2 objects. We have 6 choices for the first and 5 for the second. Or over here, 8 choices for the first and 7 for the second. This is going to give us 30. 7 times 8 is 56. With more objects, we have more choices if we're looking at the same number, 2 objects at a time. So you can use what you know about permutations